Have you ever stopped to think about where everything around us comes from? The ground you walk on, the oxygen you breathe, even the atoms in your body, all were forged in the hearts of stars. But wait, what does it mean to be made of stardust? It sounds like something out of a sci-fi movie, but it's pure reality. Stars are born, live, and when they die, release the fundamental elements of the universe. Without them, our world simply wouldn't exist. So how does this cycle work? Picture a cosmic spectacle that repeats over billions of years. Each generation of stars leaves behind a legacy of precious elements. These scattered particles become the raw materials for new stars, planets, and eventually, life itself. We're talking about a process that connects the light of the stars to the molecules in your own body. And this isn't just a scientific curiosity. It's a fascinating story, a reminder of how deeply we are connected to the universe. So how about joining us on this journey through the continuous cycle of stars? Discover how the birth, life, and death of these cosmic giants shape the universe and explain our very existence. Birth in a nebula. Imagine you're looking at a vast carpet of dust and gas out in space. This carpet is called a nebula, and it's the birthplace of all stars. But how exactly does a star come into being? Think of the nebula as an enormous cloud of material. Within it, some regions have slightly more concentrated material. Over time, these denser areas start to grow even heavier. Gravity pulls the gas and dust inward, forming a star embryo known as a protostar. The protostar isn't yet a true star because its core hasn't started the magic of nuclear fusion, but it's getting ready. Gravity continues to press the gas and dust toward the center, causing everything to heat up. Imagine it like compressing air in a balloon. The more you press, the hotter and denser it becomes. In the case of the protostar, the core becomes so hot that at a certain point it starts transforming hydrogen into helium. This is where the magic happens. Nuclear fusion begins. This fusion releases a tremendous amount of energy, and that's how the protostar finally becomes a star. In short, the birth of a star is like watching a cosmic cloud give rise to a brilliant furnace, all thanks to gravity, heat, and that special nuclear reaction. Impressive, isn't it? The main sequence and stability. Now that the star has lit its internal fusion engine, it enters the most stable and longest phase of its life, the main sequence. It's like the adulthood of a star, where it maintains a constant balance between the gravitational force pulling inward and the pressure from nuclear fusion pushing outward. Here's how it works. In the star's core, hydrogen is converted into helium. This process releases an enormous amount of energy, which radiates as light and heat. This energy generated by fusion is what gives the star its shine and prevents it from collapsing under its own weight. Think of nuclear fusion as a motor that never stops, as long as there's fuel. During this phase, the star is incredibly stable. The light we see in the night sky mostly comes from stars in this phase. They shine for millions or even billions of years, depending on their mass. Large stars burn through their fuel faster, while smaller stars like our Sun have a longer and more peaceful life in the main sequence. During this time, the star supports the life of planets that may orbit around it. For us, for example, the Sun in this phase is what makes everything we know on Earth possible. In short, the main sequence is the phase where the star finds its stability, shines steadily, and maintains the perfect balance between gravity and fusion pressure, the expansion into a giant or supergiant. After billions of years, the star starts to face a dilemma. It's running out of core fuel. Remember how the star's engine works by burning hydrogen? Well, that hydrogen eventually runs out, and when it does, everything changes. Gravity, which always tries to pull everything inward, begins to win the battle. The core shrinks and heats up even more, while the outer layers of the star expand. This expansion turns the star into a red giant, or in the case of very massive stars, a supergiant. For example, our Sun, when it becomes a red giant, could grow so large that it swallows Mercury, Venus, and maybe even Earth. Why does the star turn red? It's because its outer layers, now farther from the core, cool down and emit a reddish light. At the same time, the shrunken core begins fusing heavier elements, such as helium, into carbon and oxygen. But this only delays the inevitable. The star can't stay this way forever. The giant or supergiant phase is, in simple terms, the star's last breath before it reaches its final stage. It's a grand and dramatic period where the balance that kept the star stable for so long finally gives way to a constant struggle between gravity and energy. The spectacular death of massive stars. Now we come to the climax of a giant star's life. After burning helium, carbon, and even heavier elements like iron, the star's core reaches a point where it can no longer produce enough energy to counteract gravity. At this moment, gravity wins completely, and the core collapses violently. When the core collapses, something spectacular happens. The star's outer layers are blasted into space in a massive explosion called a supernova. If you've ever seen a really bright firework, imagine that happening on a cosmic scale. The light from a supernova can be so intense that for weeks it can outshine all the other stars in its galaxy. It's a spectacular display of light and energy in the universe. But what remains of the star? That depends on its initial mass. If the star was very massive, its core might collapse further, forming a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. If the star was slightly smaller, it might leave behind a neutron star, which is like a super-dense core with the mass of several stars compressed into something the size of a city. This dramatic death isn't just an end, it's also a beginning. The heavier elements produced inside the star are spread out across the universe, seeding space with the materials needed to form new stars, planets, and possibly life. It's the cycle of cosmic life, where a star's death is actually the seed of something new, a stellar legacy. When a star reaches the end of its life, it doesn't just vanish without leaving a trace. On the contrary, its death is a tremendous donation of matter to the universe. Imagine that within the star, throughout its entire life, elements like carbon, oxygen, iron, and even gold were being created. These elements, once confined within the star's core, are ejected into space during its final stages, especially during a supernova. The material flung out by the stellar explosion mixes with the gas and dust in space, forming new nebulas. These, in turn, give birth to new generations of stars. It's like cosmic recycling. Without the stars that came before, our planet, for instance, would never have had the elements necessary to form rocks, oceans, trees, and of course, us. In other words, all the carbon in your body, all the calcium in your bones, was forged billions of years ago inside a star that no longer exists. Furthermore, the compact remnants of stars, like black holes or neutron stars, continue to influence their surroundings. A black hole can pull in matter, releasing energy into its neighborhood and forming hot, luminous accretion disks. Neutron stars, with their intense magnetic fields and rapid rotation, can emit pulses of radiation that help astronomers learn more about the cosmos. So, the legacy of a star isn't just its light that once illuminated the universe, but also the materials that form everything we know and the influence its footprints leave on space over billions of years. It's like an inheritance passed down from generation to generation on the grand stage of the cosmos. The continuous cycle. Now that we know how a star lives, dies, and leaves its legacy, it's important to understand that this process never really ends. Stars are like giant levers in the universe that keep everything turning. When a star dies, the elements it created throughout its life aren't lost. On the contrary, they end up returning to the same place they came from, nebulas and clouds of gas and dust. Imagine looking out at a field full of flowers. The flowers grow, wilt, and then drop their seeds into the soil, preparing the way for the next cycle of growth. In the same way, the material released by stars mixes with other particles in space, creating new fields where other stars can form. It's a never-ending cycle. A star is born, lives through its brightest phase, dies, leaves seeds, the heavy elements. And in the future, those seeds help form new stars and even planets. That's exactly why we're made of stardust. Everything that makes up our world, the minerals of the earth, the water in the oceans, the oxygen we breathe, came from stellar processes. It's fascinating to think that the same star that exploded billions of years ago and spread carbon into space may have contributed to the formation of our planet or even our own bodies. So, the life cycle of a star isn't just a story that ends with its death. It's a story of renewal, constant transformation, and new beginnings. This continuous cycle keeps the universe dynamic and full of possibilities, ensuring that stars will always play a fundamental role in creating everything we know and everything yet to come.